All right, and welcome to Fractions Level 4. Now, what's our rule for adding fractions without a common denominator? And by the way, you will notice I did in fact spell the word denominator correctly in our previous video, so I might in fact also be your English teacher. But let's go ahead and take a look. What's our rule? Well, the rule is we want to create, a common denominator, which I will abbreviate, well, maybe I won't, denominator. All right, we'll create a common denominator by multiplying one or both of the denominators to get to a common denominator. Okay, so I know that that's kind of a mouthful there, but let's go ahead and pause the video, finish writing these notes down, but let's go ahead and find out what does this really mean in practice. Okay, here we have example 1. We have 2/3 plus 7/6. So notice that the 3 and the 6, our denominators are uncommon, or they are different. So the question becomes, well, can I multiply 3 by any number? So can I multiply 3 by any number and make it equal to 6? Well, most of us know this. 3 times 2 is 6, and whatever we multiply the bottom by, we also have to multiply the top by. 2. So I'll multiply both the bottom and the top by 2. And so what do I get? Well, here we have top times top. 2 times 2 is 4 on the bottom. 2 times 3 is 6 plus 7 over 6. Now I have a different shade of blue. Oh well. And 4 over 6 plus 7 over 6, well, now we have our common denominator, so it's something over 6, and 4 plus 7 is 11. And there we go. All right, let's go ahead and let's try a second example. Okay, here we have 8 over 14 plus 4 over 7. Now we know that 14, we can't really multiply 14 by a number to get to 7, but we can ask ourselves, 7 times what number will get us to 14? And most of us know this. We say, oh, you know what? We can multiply the 7 by 2. And we multiply the bottom by 2. Well, of course, we have to multiply the top by 2. And what do we get? Well, we get 8 over 14. Back to my original blue. And here we have 4 times 2, which is 8, and 7 times 2, which is 14, and 8 over 14 plus 8 over 14 is, in fact, 16 over 14. Our denominators stay the same, but 8 plus 8 is 16. Now, 16 and 14 can both be divided by 2. And so 16 divided by 2 is 8, and 14 divided by 2 is 7, and here is our reduced fraction. All right, let's move on to our third example. All right, for example number 3, we have 6 minus 5/7. And of course, how do you take a whole number and change it to a fraction? Well, this becomes 6 over 1. And now we say, well, wait a second. Can we do 1 times any number and get it equal to 7? And hopefully you would say times 7. Yeah, very nice. All right, so we can multiply the bottom by 7, but if we multiply the bottom by 7, we also have to multiply the top by 7. And so wait a second, 7 times 6 is 42 over 7 times 1 is 7 minus 5 over 7. And wait a second, what's 42 minus 5? We got some big numbers here. And of course, that'll be 37 over 7. All right. I even doubted myself there for a moment. Okay. So what about negative 8/3 minus 5? This is a little bit interesting. Well, our 5, of course, becomes 5 over 1. And you can't really do 3 times a number to get to 1, but of course we can multiply 1 by a number to get to 3. And so we'd say, okay, well, what are we going to multiply it all by? Well, we can multiply this 1 on the bottom by 3. 1 times 3 is 3. And what I do to the bottom, I have to do to the top. And switching back to our nice blue, we now have negative 8 over 3 minus 5 times 3, 15 over 1 times 3, 3. And wait a second, remember, when we have a negative minus a number, that's really the same as adding a negative. So you want to be careful there and make sure you understand what's going on. And so our denominator must be 3, but what is negative 8 plus negative 15? Well, remember, it's like you owe. If you owed your best friend $8 and you owed your dad $15 altogether, you would owe 23. We simply add them both up. All right, y'all, I have 2 final examples, and then you will be done with your first ultimate guide to fractions. All right, here we're going to include some variables. We have 3x over 21 plus negative 2x over 7. Well, we know that 7 times a number can get to 21, and fortunately, that number 7 times 3 will get us to 21. And whatever I multiply the bottom by, I multiply the top. And so what is this really going to look like? Well, this will look like 3x over 21 plus negative, and 2 times 3 will give us 6, or I'm sorry, 2x times 3 will give us 6x over 7 times 3 is 21. And now we can work on combining these things. Now wait a second, our denominators are still going to be 21, and we have a 3x and a negative 6x, so we have like terms, they can be combined. And wait, if you had $3, but you owed me 6, after you give me your 3, how much do you still owe me? Well, you still owe me $3, or in this case, 3x. One final thing, can 3 and 21 be divided by the same number? Yes, they can both be divided by 3. And so negative 3 divided by 3 is really negative 1 over, negative 1x over 21 divided by 3 is 7. All right? And now moving on to our 6th and final example. Can 36 be multiplied by any number to get to 6? Not really. But can 6 be multiplied by a number to get to 36? Of course it can. 6 times 6. We'll multiply the top and the bottom both by 6. Now let's see. What do we have now? Negative 5y over 36 minus 6 times 10 will give us 60y over 6 times 6 is 36. And wait a second. We have a negative 5y minus 60y. It's like that 60y is negative, and so altogether you would owe 65y over 36. Now, my best guess is that 65 and 36 do not have any numbers in common. And there's our answer. All right, guys, finish this assignment, and thank you so much for your hard work and effort on our first homework assignment of the year. All right, y'all take care.